Hello and welcome to the third tutorial of OpenCL C++ API tutorial series. I'm back after a long time and I'm happy for that. I finally got some free time to continue this series, and thanks for the support and love of all people who have reached out to me and have watched the previous tutorials and find them useful and wanted me to keep the tutorials going, and I try to finish this series as soon as possible, and make sure to show your support and love. It means too much for me and keeps me motivated to continue. Okay, so let's go to our tutorial. In the last tutorial we managed to compile a kernel, which the source code is here. Compile a kernel for our OpenCL device, which is my GPU in this case. And in this tutorial, as we have promised, we are gonna show you the steps of running it on the device, and that will be very awesome. In the end of this course we will be able to run our very own OpenCL kernel on our OpenCL device. So let's have a look at what we have done before. We managed to compile our code, which we wrote in the separate file, into a program, and we managed to create a kernel out of that program with an entry point with the name of test, which is here, and it's compiled and it's ready to run. So in this tutorial we're gonna run it. Let's just run our application one more time to see everything is okay. 2 zeros, which if you recall means success, so everything is good. So what are the steps we need to take to run our kernel on our device? If we take a look at our class list, there's something here, KernelFunctor, a really simple class in terms of the constructors. Just two constructors. One constructor gets a kernel, one constructor gets a program name and CLint. It's kind of familiar if you look closely. It's basically what we give here to the kernel. So either we build the kernel ourselves and pass it to the constructor of a functor, or we pass this tree to the kernel functor and it manages internally to make a kernel for us. So let's start off by simply creating a kernel functor, and out of all those two constructors I have a kernel, so I pass it. So I give it a kernel, and if you have noticed, the kernel functor is a template, and what we put inside the template, the inputs of our kernel. Okay, what inputs our kernel takes? Nothing, because we are void. But shortly in the next tutorials I show you how to use inputs, and that will come very handy. So for now just know that if we have any input we have to put it here, but for now it's empty because we are void. So I have a functor. When you have a functor, what would you need to do in order to run that functor? Just call it. It's a function, just call it, and we're done. Okay, but when we call it, you see that we need something called enqueargs. Okay, so another step we have to take is to create an enqueargs. We will talk in details what are these. We just for now we just want to go and do the work in order to run our kernels. But we will come back later and talk about the details of what are these and how we can use them. Okay, we see lots of constructors here, and as usual we need them. We use the most explicit ones because we don't want to left the decision to the default selection of OpenCL. So use these that take a command queue. So we need to get familiar with command queue. We need to get familiar with the range. Let's first command queue, and command queue is what we will see and use a lot later on. What it is, basically is where we enqueue our inputs and outputs, when we want to pass inputs to the, for example, GPU or OpenCL device, or we want to read outputs out of our OpenCL device, we're going to use command queue. So it's very important, and for making it, I'm going to use this constructor. It takes a context, it's take a device, and the rest are default. So let's make a command queue. Let's name it queue and just the context and device. That's it. We have a command queue. And if I go back to enqueue args, another thing we need is ND range. So ND range, if you see, takes one-dimensional range, two-dimensional range, and three-dimensional range. What are these? Just a simple overview. We will talk in details later on. But look at it this way. The GPU, what is a GPU? A GPU is array of processors, lots of processors, 1000 processors, for example. Okay, so these processors are there for us to run our program. But how many of them we're gonna use now? In which layout we're gonna use them now? You see, these are the questions that ND range answers. So out of, for example, 1000 processors that I have right now, I want to use, for example, 10 of them, okay? And I want to use them in a one-dimensional range. So I go here. Or no, I want to use 100 in a 10 to 10 2D matrix. Okay, I'll go here. Or 3D. It's all yours, and your problem that you're solving determines which ND range we are going to use, how many processor we're going to need, in which dimension and layout we're going to need them. And we will get to this later, but so for now we just have to know that it's like telling the OpenCL how many processors I need and in which layout I need them. So now that I've queue and I know what ND range is, I can make my enqueue args. So I call it eargs. So I'm gonna give it a queue and specify an ND range for it. I just want a 10, for example. It's a lot. Let's use less. I want a 5. I want a 5 processors. My kernel is just a hello world, so I basically need just one, but let's 5, and that will give us something to talk about later. And I have everything to give to functor. Oh, I'm sorry, okay. Now it's done. I'm ready. Are you ready too? We are about to run our first kernel on our GPU. What a exciting moment it is. Run it and see what will happen. And tada, something had happened. And those hello words are gonna sell something. And we will talk about it later, but for now, first of all, congratulations. We've managed to step by step run our program on our GPU. And what we learned today basically is for our kernel, after we build our kernel, to run it, we need a functor. And we just need to call that functor. But that functor, at the very least, just takes one argument, and that's eargs. It can take more if our kernel have more inputs, but our kernel have no input, so functor just takes one input, and that's eargs. And in order to create eargs, we need to create a queue. In order to create a queue, we need context and device, which we had before, and we need to specify the ND range. But for now, we play with 1D array, and we just specify the type, so the number that so I want a 5, and we just call the functor with the ERs, and again we run it, and here it is. We told this to print hello world, and it printed 4 hello words. Why 4? And what other things that we have to talk about here? What is this? These are the subjects of our other next tutorial, that we are gonna talk specifically about the syntax of this kernel and the mistakes that we made here. So make sure to stay tuned for more about OpenCL. This was the third tutorial, which we managed to run a buggy kernel on our OpenCL device, which is my GPU.